Let's take a look a little bit at solubility, or we're going to specifically look at how a solute dissolves into a solvent, whether it can, and how much is going to be able to dissolve. So first we need to think about how we know if something is soluble. Something soluble means that it's able to dissolve into a particular solvent. So a solute can dissolve into a particular solvent. There's various levels of solubility, so something could dissolve a little bit or it could dissolve a lot. This is actually related to our polarity that we looked at previously. So we'll look at what happens with polar, nonpolar, and ionic compounds. The main principle that we'll be looking at is like dissolves like. That means that similar compounds are going to dissolve into similar solutions. So if we have a polar solvent, what that means is that that will dissolve polar molecules and ionic compounds. Because remember, a polar solvent is a covalently bonded compound, so it's a molecular compound, but the particles have a partial positive and a partial negative end. So the classic example of this is water. So we have oxygen, hydrogen. This is the classic polar solvent. And so polar molecules will dissolve in water, and ionic compounds will dissolve in water. Nonpolar solvents, they're covalently bonded. They're molecular compounds that are nonpolar. So this can be oil, gas. So you can think about things that won't mix with water. Because if you try and mix a nonpolar solvent and a polar solvent, that's when you create layers. So if you put oil and water into a tube, you can do this at home if you have these around, you'll end up with a layer of oil and a layer of water. So oil, water. And you can actually see this layer if you do this experiment. Now, this tells us, what types of compounds will dissolve with and what type of a solvent. But we also need to think about how these compounds dissolve. Now we're going to specifically look at water. Water is our big solvent, so a lot of the stuff that we're going to be doing is polar. So we're going to look at polar compounds. So we want to look at how compounds dissolve. So it's based on their degree of dissociation. So dissociation is a measure of how much something breaks into ions. So you may have heard the term electrolytes, and electrolytes really refers to something that breaks apart into ions. So a strong electrolyte dissociates completely, so it completely breaks into ions. And we'll look at some examples of this in just a moment. Weak electrolytes, they partially break into ions, and they weakly conduct electricity. Non-electrolytes, they don't break apart into ions, and they don't conduct electricity. So if we actually do a little experiment, we can put various solutes in here. So each of these solutions has water in it, and this one has water plus ethanol. So notice that this light bulb, it doesn't light up because there's nothing to conduct the electricity. You don't have any ions that are broken into the solution. KCl here is an ionic compound. So ionic compounds, it's made of ions. It can break into ions when it dissolves into water. And so you can see that there's these negative ions and positive ions that allow for the electricity to flow through the water. This last one is acetic acid, and we'll talk about what type of compound that is, but this is a weak electrolyte. So you can see it's weakly, the light shines just a little bit. With the potassium chloride, the light shines really, really brightly. Super shiny. Because it conducts electricity very well because there are ions broken up in the solution. So let's take a quick look at what's going on for each type of electrolyte. So a strong electrolyte, ionic compounds, it's going to break apart. So if I have, for example, here's two different examples of ionic compounds. So this is where the identifying what the ions are and how they break apart was important from previous topics. So sodium phosphate here, there's 3 sodium ions. So we break it apart into 3 sodium ions and 1 phosphate ion. Iron 2 hydroxide breaks apart into iron 2 plus and 2 hydroxide ions. So you want to think about how does this ionic compound break apart in the solution? A weak electrolyte, so we have some molecular compounds, some ionic compounds, so you wouldn't necessarily be able to identify those yet. We'll have some later on in the course. So these only partially dissociate. So you'll notice this is acetic acid, and it's dissociating, so the H+, so the hydrogen ion and the acetate ion are breaking apart. But notice this arrow. It goes both directions. So what that means is that this acetic acid breaks down into the hydrogen ion and the acetate ion, but this hydrogen ion and the acetate ion can go back the opposite way. So this reaction is going back and forth, and we'll look at that a lot more extensively when we look at equilibrium. But notice that different arrow. So that's going to be important when we're looking at weak electrolytes. The last one is non-electrolytes. So these are typically molecular compounds. So they don't dissociate. And we have, so this is sugar. Sugar, we add water to it, dissolves, and notice that the only thing that changed was the physical state. It went from solid to aqueous. That's the only way we can tell that something has changed here. Now I'd like you to try and predict the products for these electrolytes in water. First, you'll need to determine whether it's a strong or a weak electrolyte. And you can do this by looking at the solubility. So you look at your solubility rules. Based on the solubility rules, if it is soluble, then you're going to have a strong electrolyte. If it is insoluble, then write it as a weak electrolyte. So this is kind of combining some things from some previous parts. So do make sure and combine that together and determine what would the products be. How would you write this reaction for these dissolving in water?